Well, we've spent a lot of time analysing different features of time series plots, increasing trends, decreasing trends, seasonal and cyclical variations and random variations. We haven't done a lot with seasonal variations, mainly because it's really hard to tell a general trend. This is a picture of a time series plot with seasonal variation. It's really hard to tell a trend when you've got this seasonal thing going up and down all the time. So what we're actually going to do is we're going to learn a tactic to transform this, similar to how we transform scatter plots. We're going to transform this into a deseasonalized. We're going to take out the season factor, and then we can much more clearly see the trend. So this is what we will start with, and we'll learn how to get to this, and this is what we'll end with. And we can actually see, like, it's very hard to tell here that there's an increasing trend, but here it's very easy to see that there is an increasing trend. And again, you can see there's a couple of, like, a dip in the business and a spike in the business. And maybe they could, like, analyse their business and say, why do we sell particularly more here regardless of the season, and particularly less here? What did we do wrong? What did we do good here? So we're going to be able to take out all the seasonal factors, like the fact that it's Christmas and we're selling more, or the fact that it's winter and not as many people are coming into our shop, or the fact that we're a coat store, so in winter we're going to sell more. Take out all those factors, and then we're just going to be left with the raw information that tells us how we're doing for our actual sales, regardless of what the season is. So that's our aim, to eliminate these long-term kind of patterns that we see coming up and just really see the raw data. So what we're going to do is we're going to find the seasonal indices, and we'll go a bit more over what they are in a minute. But in general, just a few pieces of information. The average of seasonal indices has to be 1. So if we're going to add all of these numbers up, here's some seasonal indices, and again we'll see how to get them in a minute, but these are some seasonal indices. If we add all of these up and we average them, the average should be 1. So what we're saying is there's 12 here, so if I add these all up they should equal 12, because then I'll divide it by 12 to find the average, and that'll tell me whether that's the average is 1 or not. So here's another way to say it: the total sum of all the seasonal indices must be the same as the number of seasons. So for example, 4 seasons means the seasonal indices added all together must equal 4, and then if we're finding the average, you add them together and divide them by how many there are, which is 4. The average will be 1. So let's just do one here. Let's add up 1.1 plus 1.2 plus 1.1 plus 1.0 plus 0.95. I'm just going to add all these up. Plus 0.9 plus 0.9 plus 0.85 plus 0.85. I'm just trying to find the average here. So we're going to add them all up and divide them by the number of data. You'll remember the mean or the average is add everything up, divided by the number of data, 12. When I do that in my calculator, let me just check that. Yep, that is 1. So all of these top ones added up to 12, and then 12 divided by 12 was 1. What does that tell us? That just tells us that the person who made these seasonal indices for this data was correct. But often we'll get given questions where one of them might be missing. So September might be missing, and we'll need to figure out what's missing to make the whole thing add up to 12. Or if there was 4 boxes, what's missing to make the whole thing add up to 4. We're going to see a lot of 12s for months, 4 for seasons, sometimes days of the week, so 7s will come up a bit as well. We'll look a bit how to get the seasonal indices, but just as a general rule, you need to understand that they all have to add up and average to the number 1. Otherwise, you've done something wrong. Right, that's your first piece of information. Second thing, when we're reporting, we need to report on the percentage that this seasonal index tells us, rather than just the number. So rather than just saying June was 0.95, we would say June was 5% less than the average. So the average is 1. So let me show you how we do that. For instance, if our seasonal index was 1.2, we're going to go 1.2 times 100, like to make it a percent. So 1.2 represents 120%. We're just going to take off 100% to help us to see that that's 20% more. Now, I reckon most of you could see that 120% is 20% more than the average, or 20% over the average, but here's the formula that will cater for it all. So this season averages 20% more sales than the average season's sales. The average was 100%. Here's another example. If the seasonal index is 0.9, we do 0.9 times 100, which tells us the seasonal index represents 90%. And then we'll do 90%, take away 100%, which is negative 10%. That tells us the seasonal average is 10% less sales than the average season's sales. Number 3, if the seasonal index is 1.15, 1.15 times 100, same thing again, equals 115%. So 115% minus 100% is 15%. So the season's average is 15% more sales than the average season's, and that should say sales. Thanks, photocopier. Sales. So this is the formula here. The seasonal index times 100 minus 100. Minus 100% really, but that'll make that into a percent. So we just need to get into the practice of doing that. Let me give you a few visual ones for this data. So for instance, April is 100%, which is exactly the average. July is 90%, 10% less. November is 1.1, that's 110%, 10% more than the average. This one's 20% more than the average. And after a while you can get practiced and see, well, this is 15% less, even without having to do the maths on that. Practice makes perfect. Let's keep pushing through. Let's actually now look at how you would find a seasonal index. This is going to take a little while, so I'm going to stop the video here and start the next one in terms of just the working for finding this seasonal index.